Welcome to your favorite intermediate algebra course. Today we're talking about using the fundamental theorem of algebra. Now, the fundamental theorem of algebra was first proved by a guy named Carl Friedrich Gauss in the 18th century, and it states if you have this polynomial f of x, we'll call it just like this f of x equals x cubed. You know, we got this polynomial right here, x cubed minus 2x squared plus x minus 2. If you have this polynomial and your degree is greater than 0, which it is, this degree is 3, right, x cubed, then you have at least one 0 in the complex number system. And then mathematicians went a little further with what's called the linear factorization theorem and said you have at least 3 linear factors, which means you have 3 zeros. Okay, so what I'm saying is that you have the number of solutions, or the number of zeros, is equivalent to the degree here. Okay, and it all stems from the fundamental theorem of algebra. Okay, so you have, since this is degree 3, x cubed, you have 3 zeros, right? Now remember, zeros are the same thing as an x-intercept, right? Okay, so if your 0 is k, let's call your 0 being k, that means it's the same as an x-intercept, i.e. f of k equals 0, right? That's what it means to be a 0, okay? So it's an x-intercept. It's also a solution to the equation 0 equals whatever your original polynomial is, so they're solutions. And if you have k is a 0, then you know that x minus k is a factor, and we kind of talked about that last time. Okay, you know that x minus k is a factor, all right? So back to this problem we're doing here. So it's x cubed. That means we have 3 zeros to this. Now, what if we were finding all these solutions? We're finding all these zeros, finding these x-intercepts. Well, we'd let y be 0 to find an x-intercept, right? And we'd solve this. I say, well, there's 4 terms. How about we try, first of all, factoring this by grouping? I say, well, let me take an x squared out of each of those. And you look over here, and I'm like, well, I can't take anything out of each of those, but let's go ahead and think about that as a quantity x minus 2, which means there's a 1 in front, right? So you're just going back to this factoring by grouping. See, I can take out an x minus 2 from each of those terms. You see it there? Take the x minus 2 out. What am I left with? I'm left with an x squared plus 1. Right? So 0 equals x minus 2 times x squared plus 1. So again, to find the solutions, you let f of x be 0, right? You're finding your zeros, you're finding your x-intercepts, you're finding your solutions. And then you take each of these and you factor it as far as you can. Now this x squared plus 1, we can't factor that any further. So to find all these solutions, we just take each of these, set it equal to 0, and we solve. There's one of our zeros. X squared equals -1. We go ahead and we square root that. X equals plus or minus I. Okay, so you have 1, 2, I, negative I, and 3, the 2 over here. You see how you have 3 answers here? You have 3 solutions, right? Let's do another one here. How about, you go second problem. Again, we're doing the same instructions here. Find the number of solutions and the zeros, and then go ahead and find the zeros. So f of x All right, how about this one? First of all, how many zeros do we have? I say, well, this is x to the 4th, right? 4th degree. That means I have 4 zeros. I should have 4 answers at the end. And to find our zeros, we let y be 0. And then we're factoring this thing. Now, you notice each of these, I can take an x squared out, right? And then now I can just go ahead and factor that. Old school. Factors of 4, whose difference is the 3 there, and I say, oh, that's got to be the plus, that's got to be the minus. And then we say x squared equals 0, x minus 1 equals 0, x plus 4 equals 0. And then x, now you notice that this x squared, in all actuality, this is x times x, right? So I kind of have 2 of these. x equals 0, x equals 0. Do you see how I have 1, 2, 3, 4? I actually have 4 zeros. When you get that repeated 0, that's called, okay, you see the x equals 0 and there's 2 of those, right? You call that x equals 0 with multiplicity. In other words, how many times did it happen? With multiplicity 2, there's 2 of those zeros, right? If I had 3 of them, I'd say with multiplicity 3, right? You notice again, we have 4 zeros here, okay? Let's go ahead and do something a little more involving here. How about, actually, let me go back. All right, now this will be a good review also from that last section, from 6.6 it was. The first thing, you're looking at this and you're like, okay, wait a minute. It's x to the 5th, that means I got 5 zeros, right? At the end of this, when I'm finding all my zeros, I should have 5 of them. 5 of them, okay? Or x-intercepts. And the question on this one is, you're like, man, I got no idea where to start on my factorization, right? I gotta factor this thing down. So I think about what, first of all, number one, what are my possible zeros? Possible zeros. So I say factors of 8, right? Factors of p over factors of that 1 in front, right? Factors of 1. So I say, okay, plus minus 8 over 1, plus minus 4 over 1, plus minus 2 over 1, plus minus 1 over 1. Okay, so I got 2, 4, 6, 8 of them I got to try. And then I go to the side, and I say, well, let me see which one of these work. If they are truly a 0, then the remainder will be 0, right? R equals f of k, which equals 0. So when I try it, so like let's say let's try 1, right? When I try 1, let me write this. Okay. When I try 1, right, if it really hits there, right, so that's my k, I'm claiming k, that 1 is a 0, then that means x minus that number is a factor, right? And I'd have to figure out the rest, okay? So if it's truly a 0, that means my remainder must be 0, right there. If I don't get a remainder that's 0, that means x minus 1 is not a factor, right? And then I'm going to try, instead of 1, instead of the positive 1 right here, I'm going to try the negative 1, right, next. Then maybe I'll try the 2, and then the negative 2, and so on. And of course, I could have started with 8 and negative 8, but I like to start with the smaller numbers, the 1 and the negative 1 first, okay? So we go ahead and try it, and we say, well, let's see if this 1 works, right? So I'm going to take x to the 5th, blah, 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 divide by x minus 1. So k is 1. Let me write the coefficients here of that x to the 5th. So I got 1, negative 2, negative 3, 6, negative 4, and 8. Okay, so it looks like I drew this wrong. Okay, so 1 comes down. Oops, already messed up. My goodness. Uh-oh, it's a 6. So that didn't work, right? So it's not a factor. So x minus 1, I go over here and I erase it. Nope, that's not a factor. So let's try, how about we try negative 1. Let's see if negative 1 works, right? Okay, let me go over here, go negative 1. right? And I try negative 1. Does that give me a remainder that's 0? And guess what? It does not, okay? So I say throw that one out, right? I try the next one. How about 2? Go through that, right? This is how you do it, you guys, without a T89. Okay, so 1, 2, 0, 0, negative 3, negative 6, 0, 0, negative 4 times that 2, negative 8. Aha, there it is. Ooh, that means on my graph, let me erase some of this. On my graph, I know I hit right there too. So I know x minus that number, minus x minus the 2 is a factor, right? And now I put my answer right in here. Okay, so it's 1x to the 4th plus 0x cubed. Okay, I'm looking right here, even though my answer right here that I got for the division. 0x cubed minus 3x squared, 0x, and then minus 4. Okay, and now I'm going to factor this one right here. And I'm like, hey, that's quadratic in form. It's quadratic in form, right? So that would be a minus 4 plus 1. And I can keep going. X minus 2. This is x minus 2, x plus 2, right? That's where I got that. And then x squared plus 1, I'm stuck right there. I can't do anything with that. Okay, but I'm as far as I can. I'm factored as far as I can. I take each of these. X minus 2 equals 0. So x equals 2. Get another x equals 2. So I say with multiplicity 2 here, right? That counts for 2 answers. I got a negative 2. There's 3 answers. Now I got to, you notice this is not a linear factorization. I got an x squared on this, right? But I couldn't factor it any further. So I just said equals 0. I solve it, just like we did on that last one. And I'm like, oh, guess what? I got a plus minus I again on this. So there's 2 more answers. So 2, 3, 4, 5. I got 5 of these, okay? Now a little bit about that with multiplicity too, okay? If you have even multiplicity, like that too, okay? We have a repeated 0 there. That means on the graph, I just touched that. So I either touch it just like that, or I'm just touching it like that, okay? Whereas if it's an odd multiplicity, okay, like let's say at that negative 2 I had multiplicity of 3. Let's say I had 3 of those negative 2's right there. I would know I crossed through it, okay? And of course your I, that thing's not going to show up because we're graphing on a Cartesian coordinate system, which is a real numbered line by another real numbered line, okay? But there's my 5 zeros, and that's how you go about finding those. Okay. Okay, what one thing you want to keep in mind is that complex zeros come in pairs. Okay, you notice like on both those last couple problems that we did, we had I, and then we also had negative I, didn't we? So if they come in pairs, that means if a plus bi is a 0, then you also know then a minus bi is a 0. And guess what? It goes both ways. If a minus bi is a 0, a plus bi is a 0. So that's an if and only if statement there. Okay? Let me stop this here and I'll get to the next video in just a second.